everyone. My name is Dinesh Bhattrai. I am doing Masters of Civil Engineering at University of Wollongong. Today I am going to present a presentation on design of building to resist progressive collapse, analysis of design procedure. Today in this slide I will overview through the introduction of my topic, review of the journals, research design methods, its results, limitations and references that I used in this presentation, in this paper. Introduction. The keywords of my topic are progressive, collapse and resist. We all know that progressive means advancing, collapse means damage or destruction. So at an overall, progressive collapse means the distribution of a starting local failure or local damage from member to member, leading to the damage of overall building or separation of whole part or big portion of the building. So to resist means to withstand it. So overall progressive collapse, it needs to be to resist the progressive collapse. In this picture we can see that at the 18th floor a small gas explosion can lead to the collapse of whole building, and on the right side it is a pictorial view, whereas on the left side of the slide there is a real view of how progressive collapse damages the whole building. So a failure of one member at one end, a failure of one small member can lead to the damage of a whole building or a separation of a big part. It can lead to the collapse of entire structure. So we need to be aware about it. Practically, the occurrence of progressive collapse to be minimized to zero is impossible. We cannot minimize the occurrence of progressive collapse to zero, but somehow we can minimize its occurrence. It is the best solution for resisting the progressive collapse and to resist the adverse effect of it. For that we can use seismic design, seismic provision provided by the code can be used to resist progressive collapse, and it does not cost much. It does not differ the overall cost of a building or a project. Small change in design and some additional expenditure of cost in building can be effective for progressive collapse mitigation and strengthening strategy. We can adopt the strategy of strengthening and mitigating the progressive collapse by use of seismic codal provision with some small additional expenditure. Review of journals. 3 journals I have presented here. 3 journals by Meyer and Gosson 2016, Brunesi et al 2014, and Zhang et al 2012. In a journal of Meyer and Gosson, original damage of one segment might lead to collapse other segment, generating a chain reaction. In progressive collapse, a chain reaction is formed and gradually increasing. It leads to the entire framework, leads to the damage of entire framework. Whereas in Brunesi has mentioned that load effect caused by man-made hazards such as gas explosion, bomb blasting, or the natural hazards like earthquake, tsunami can overload the structure member and cause the collapsing of one or more members. And Zhang et al has mentioned that after the prediction of the vulnerability of truss can be drawn on, and if we are able to predict the vulnerability of a truss structure, then we can adopt some action to prevent the continuous destruction. That is progressive collapse. Research design method. For this research design method, experiment was done with 2 specimens of cylinder 150 by 300 and 2 beams of 150 by 150. One cylinder and 1 beam specimen was done with with seismic provision, and other was done with normal provision. Concrete used for this experiment was of 20 MPa strength, and concrete mix was from Cement Australia was used. Reinforced detailing, as you can see in the slide, reinforced detailing was done as per seismic design and detailing of reinforced concrete building in Australia. These two figures shows the detailing of the reinforcement of a typical beam and column. It is according to the seismic codal provision provided at Australia, used in Australia. Method. First of all, dry materials were mixed to form a homogeneous distribution. Water cement ratio was less than or equivalent to 0.45. Workability of concrete was tested by slump test method as per Australian standard. Experiment was conducted after 28 days of curing of cylinders and beams. Compressive strength of the concrete was carried out on the samples followed as per Australian standard. Result. The result of the experiment was use of seismic design provision helps to prevent the progressive collapse because it upgrade the strength capacity of a member. Providing the another solution to the progressive collapse is providing alternative path for load transfer. So that if a load path is obstructed by the failure of a member, then it can adopt the another alternative path to transport load from top to the bottom. And it was found that the strength of the specimen or building with seismic design is much more greater than that of the normal design. Limitation. The limitation of this paper is that the design is fully based on the seismic design provision, and the critical point of failure is just assumed. Now in these slides you can see the references that was used during the process of this research paper. These are the references you can see in these two slides, the references that I have used. If there is any suggestions or inquiries, you can mail me at the mail ID shown in the figure. Thank you.